Okay, again, welcome to this talk where we'll see how we can monitor our vCenter appliances through the vCenter REST APIs. My name is Rudi Martinsen and I'm working on automation and integration. I've also done a lot around performance monitoring over the last years. I am a V expert since a few years. I'm also part of the leadership in vMug in Norway. So a short agenda for this session. This will actually be a kind of a sequel to a similar talk I did here last year, where I showed how I built a performance monitoring solution based on open source tools like Influx and Grafana. So now we'll add the vCenter to that solution, and we'll use the vCenter APIs. So we'll have a quick introduction to those, and we'll also see how we can start to explore them. So just to have a short recap of what I did last year. My solution, I had some PowerShell scripts pulling data from vCenter and storing them in a time series database, Influx DB, and then visualizing them in Grafana. So both Influx and Grafana is open source tools, which are very easy to get started with, configuring, setup. And I did a whole lot of blog posts around that, so the QR code links to that. I also showed how we could add in, for instance, a storage array into that solution, so we got kind of a single pane of glass, a single UI for monitoring our whole infrastructure. So a quick demo of that solution. Unfortunately, it's a video, so because I couldn't use my own computer, but I think it will be fine. So this is just a simple dashboard with showing CPU memory over a small lab environment. So we have some VMs, we can see some details about them, and also the hosts at the end here. So a nice UI with lots of information. We can also drill down into a specific VM, also using the filtering capabilities in Grafana for singling out a specific cluster or a host or what have you. And we see the panels update accordingly. In Grafana you can also easily zoom in on a specific time range to pinpoint your issue. And we can also now drill into the host for this VM, and we see the time range is kept also, so so it's very easy and great help in spotting issues. So, but now we will add in the vCenter to this mix, and we'll use this management interface, the VAMI, as kind of a guidance on what data we want to pull and how we could visualize it. So, of course, this interface itself gives lots of great information, but if you have multiple vCenters, it's cumbersome to log into every one of them to check the status, and maybe your vCenter is on a lockdown network and you can't access it from your office network. So we need a way to pull data and incorporate it into the same monitoring solution. So to do that, we'll use the vSphere APIs. And as most of you probably know, until recently, most of them were SOAP based. So SOAP is a protocol, like HTTP is a protocol. It's quite cumbersome to use, especially for a guy like me who's not a developer, just an operations guy. So, but the way forward for most of the industry is delivering REST APIs. So most products today ship with a REST API, and REST is a much easier way to interact with an application. So it's built on some standards or principles, as they are called. It's not a protocol, it's not a standard, it's just built loosely on some principles. So it's much easier to use using standard HTTP methods. And what we'll see is that most of the new stuff coming will come through the REST APIs. So how can we set out and start exploring the APIs? Well, there are multiple resources available. We have the VMware Code site, which is a great resource with lots of documentation and examples. You have a tool called Postman, which you might know, where we can add in some collections, which they are called, so we can explore our APIs. And we also have the API Explorer directly in your vCenter appliance, which can do live queries against that. And of course, PowerShell, curl, and every other command line tool has some kind of a way to interact with REST. So again, a short video on that. So this is the VMware Code site, where there's lots of great information. You have the sample exchange, which gives, which you can download some examples from people. This is the API Explorer. We see there are 79 APIs across the VMware product stack. We'll filter in on the vSphere APIs. So there's 6 of those available, and we'll use the automation API, which gives you access to the appliance part and also the vCenter inventory. Notice that there are different versions available, and there are differences between the versions, so be sure to use the documentation for your specific version. So we'll drill into the appliance part. We will check out the health endpoints and use the memory endpoint when that loads to see how the documentation is. We see the documentation gives you information about how you should build your HTTP requests. At the top there, you get some description on the expected output and how that is formatted. In here you also have the related code samples with the link to the Postman resources I mentioned. So this article describes how you can download them and then import them into your Postman client, which will be the next part of this demo. So we'll head over to Postman. I've already imported the collection here, so we have the top one here is the appliance stuff. So probably a bit difficult to see, but now we'll focus on the same memory endpoints. So in Postman, there's also this concept of environments where you can add in your details for your specific environment. So the vCenter address, the username, password, etc. Of course, you'll use this in a lab environment and not your production one. And we can start exploring now by logging in to our appliance. So this is a live query to a specific vCenter appliance. We get back something called a session ID token, which Postman now will use in the background for the subsequent calls. And by hitting this into the memory endpoint, we'll get that the response back. So this is the API Explorer, which runs in your vCenter appliance. Again, first off, we're logging in to our appliance. And we see the same health endpoints available. So we'll again use the memory endpoint just to show up a bit of information about the expected response and then the actual response. So this is a live query to our database. We see we have now a session ID also, as we saw in Postman. Another thing that's great with the API Explorer, it gives you a example on how you could do this through curl, which is a Linux-based tool. So the only thing I need to do is paste this one into a curl client, and this client doesn't know anything about my vCenter on beforehand, but just by this string, I get the same response out. So it's very, very easy to get started with doing REST API calls. So this is vSphere 6.7 update 2. So you have that same API Explorer now inside your vCenter UI. So it uses the same login as you have for vCenter, and you can get the response as we have seen now a couple of times. So there's multiple ways of exploring the APIs. And it's easy to get started with it. So now let's see how we could actually pull data from vCenter and store into Influx. So we will use the same Influx server and use the same Grafana instance to visualize the data. So you have only one place to log in, one place to check for your status. And again, we will use the VAMI interface as kind of replicate a lot of the stuff inside here. So that's our next demo. So this is the VAMI for this appliance. We have lots of information here. We have at the top the host name and version number, etc. We have the health status with the green check marks. There's also a part of, or the monitor part of the VAMI, where we can see the CPU memory utilization, the utilization across the disk partitions, network metrics, database utilization, etc. And finally also the services, where we can see the health and state of each and every service. So all of this is information that's interesting to pull into our Grafana instance. And we'll start off by pulling the version number and such. So we'll log into Influx. I'll list the databases. I already have a VCSA database, but I'll create a new one just to show how easy it is to get up and running here. So in Influx, things are stored as measurements, which we can refer to as tables in standard SQL. So just to show that this database is empty, I have some scripts ready for pulling the data, and I'll specify the environmental details. Of course, you won't have your password in a script like this, but for demo purposes, please forgive me. So the first part is for logging in to the API. If I check the response of that, we can soon see the same kind of session ID as we have seen in the API Explorer and also Postman. And this will be used in the subsequent calls. So in this first script, I use two endpoints, the system version and the system uptime. Makes two API calls, both very, very fast, so no issues there. And we'll check out the version output. And we see we have some nice information. We have the install time, we have the build and version number. So all of this will now be posted to the Influx HTTP API through the point protocol and the syntax there. And Influx is a schemaless database, so things will now be created on the fly. I don't need to pre-create that table. So I've posted data into Influx. Head over there again, list again the measurements or the tables. We have now the appliance info measurements. I can do my favorite select star from, and I see I have my values. So now I'll head over to Grafana. First off is to create a data source, which is the link between Grafana and the Influx server. So specify the URL of the Influx server and also the database name. And now I can start creating my dashboard. So adding a query first, specifying the data source I just created. So see I have my one measurement there, the appliance info, and I also have the values. I'll change the visualization type, as this is not a graphing metric. And as see, I now have my first actual value from this appliance. So Grafana also a very easy to use tool. It's great it's easy to restructure the dashboard as you see fit. So I'll now just quickly duplicate this panel a couple of times to add in the three or the two remaining values. So first the build, and then finally the uptime. So the uptime is given in seconds. So in Grafana you can specify which kind of a unit a value is to have a more human-friendly visualization. So this adds up to a month. And now with just a few clicks, in a few minutes, I've been pulling data from my vCenter and visualizing them in Grafana. So next up, I'll try to replicate the health status, which is probably more interesting information to have. So a script for that as well, built in the same way. First we'll authenticate, then we'll use the health metrics. So in this case, there's a lot of metrics which will result in a lot of API calls. I'm also using the last check endpoint for pulling the timestamp, which I'll use in Grafana or in Influx. And I'll iterate through all of those endpoints, building my output, which I'll post to Influx. You might have noticed that the output for the health information, it's maybe difficult to see, but it gives this nice value of green. And while we humans could understand that this is probably good, the computer doesn't necessarily know that green equals to good. So I've done my own little mapping from the textual value into a numeric value, which I'll show why in a bit. So I'll run through that script. It was kind of 9 endpoints or something, but it runs very, very fast. See, I now have my measurements created. And I see I have the health status of the memory endpoints. So let's try to visualize this in Grafana. I'll select now the visualization type directly. So this is the single set type. Again, selecting the current or the last value in that measurement. Specify my data source as I did previously, and then select the correct measurement, so the memory one in this example. And it defaults to the numeric value, but I could choose the text one if I wanted to. But as we'll see, a black box saying that things are green is not kind of a cool visualization. So now to why I did that numeric value mapping. If I now select the value and get that numeric value, the 0, I can use the coloring feature in Grafana to add some liveliness to the dashboard. So this is based on numeric values, that's why I did that mapping. I can also add in the threshold, so when the value hits 1, it will turn orange, and 2, it will head red. So I now need also to re-engineer that mapping to a textual output, which will be displayed in the panel. You could use whatever string value you would or you want, but I've kept the API output, so green, orange, and red. And now my dashboard starts to look more interesting. So I'll duplicate out this a couple of times and select a few other health endpoints. So first the load. Give it the correct title. And then finally also the system health. And now my dashboard starts looking more interesting. Now let's try pulling the CPU memory utilization. So another script built in the same way, authenticating first. There's 2 metrics to pull, but this will be pulled from the endpoint, the appliance monitoring endpoint, and you also specify the interval. So in this case, the 5-minute interval. So I'll run through this script, and then head over to Grafana to pull out my data. I'll select a different visualization type this time to make my dashboard even cooler. So again, selecting the last value, specifying the correct data source, and then my CPU value. So now I have the CPU utilization. Again, I can use the unit component in Grafana to specify which kind of unit it is. This is percentage, and also give the third threshold. So let's duplicate this one and also have the memory visualized. and I don't like it to be yellow, so I'll just adjust my threshold so everything is nice and green. And we see now, in just a few moments, we have been building out a dashboard, pulling data from our actual vCenter and creating a nice visualization. So it's it's easy to get started with, and you can really build out cool stuff with this. I have two more scripts. This is for pulling the file systems and the usage across the file systems. This is actually using the same endpoint as the previous script, the monitoring endpoint, but with a different interval, because you probably don't need to pull the storage utilization every 5 minutes. Finally, I have the services. So one thing to be aware of is that there's two different types of services you can pull. It's the operating system one for the appliance, and also the vCenter services, which is controlled by the vMon component. This gives also the same kind of textual output, healthy with warnings, etc. So I've done the same mapping there. And in light of time, I've pre-created a dashboard showing these values as well. And now we have a nice dashboard with lots of green boxes and also the storage utilization. So just to show how this could actually give you some value, if I now stop one of the services, just to see some changes in the dashboard. So this was the vSphere client or the vSphere UI. So the service is now stopped. I can verify that by refreshing. I get my 503, and in light of polling intervals, I'll just fast forward the video, and boom, I have my red box displaying that there is some issue, something to look at. So again, in just a few moments, just a few scripts, we can pull data into Influx, visualizing in Grafana, all using open source tools. So that concludes the demos. I have done a lot of blog posts around the whole performance monitoring solution thing. That's the first one. Also what the QR code links to. The specific one for this appliance solution is the number 2. And all of the scripts I've used is available through my GitHub. So feel free to check those out. And with that, I think we have a couple of time for questions. So if there is anyone, you can. No, we have not. I got the no, so I'll stick around. So please come up later on. So with that, thank you.